Alright, so let's take an in-depth look at one of our X-linked disorders that I actually have. So what is color blindness? This is your chance to ask me any question you want about my disorder without me getting offended. So first we need to know is figure out how our eye works. Our eye works just like a digital camera does. You can see how we have light coming in. It hits our lens, just like a lens of a camera. Our lens distorts the image and puts a upside down image really on our retina. And we have cells in the back of our retina that act like pixels, and they record it, flip the image back, send it to our brain, and let our brain think about what we're seeing. So those pixels in the back of your camera are what we are equivalent to cones and rods. They are color receptors or light receptors. They're sensors that pick up on this light. They convert light energy into electrical impulses so we can make sense of the world around us. So here's a cone. This is the kind of basic look or shape of a cone. Cones provide clarity of image, how sharp it is. They provide central vision. They detect color, and they define details in things. Or you have rods, which are about your peripheral vision, your side vision. They detect motion, and they're pretty much responsible for your night vision as well. So a little bit more about these cones, specifically their color receptors, because that's where mine don't work too well. Lambda, which is this strange little symbol at the end of each of these bullet points, that's lowercase l actually in Greek. In the Greek alphabet, it's not really an L, but it's like the equivalent of L. It's called lambda, and it measures wavelength of light and other waves. So we have red light, which you can think of as having long wavelengths, and you have green light, which you can think of as having medium wavelengths, and you have blue light, which has short wavelengths. Depending on what wavelength hits this cell is going to determine what color it registers as. So you have red rods, green rods, and blue rods back there, and depending on which wavelengths go, they activate the different ones. In color blindness, most commonly, one type of your cones don't really work. My red cones don't really work too well, so I can't pick up on those long wavelengths. This means I can't really distinguish between red and green hues, because green would be the medium one when they get hit. My green ones pick it up, thinking that, hey, it's a medium wavelength, because my red ones really don't work, so I see something, but it's really just my green ones that pick it up. So they call this red-green color blindness, and I only see kind of hues of these colors. I can distinguish between them most of the time. However, the difference between red and green is not very evident to me, and I do mix it up a lot. So with that in mind, that's pretty much how my color blindness works. So if you show me something that's purple, purple looks blue to me because I don't see the red that's in it. In order to get purple, you need blue and red. So there's long wavelengths my cones don't pick up on, and they do pick up on the blue ones though. So I see, I have trouble distinguishing between blue and purple because I don't pick up on the red, which is the only difference between them. Same with orange and yellow and other colors like that. Well, that's pretty much how it works.